And now I'm happy to invite all our speakers online to discuss these challenges and opportunities. Now we will see on the big screen all our speakers. Professor Zhang, please activate your camera. Professor Yu, yes, thank you. You are on a big screen, please smile. Dear colleagues, once again, thank you very much. Thank you very much for the connection. I'm extremely happy to see and hear all of you. So you raised global challenges, and now it's difficult to find the appropriate question to ask all of you. But whilst I was listening to you, I had an idea. About 20 years ago, we started actively dealing with the visualization. So OCT came on stage, spectral tomography came. So we immediately started facing these challenges. For example, you get information from one machine and you cannot transfer it to the other machine. So, for example, first studied Cirrus and we cannot monitor on Spectralis. Yes, we cannot proceed. Also, you tackled lots of problems. Databases, for example, if database is Chinese, so it cannot be copy-pasted and fully extrapolated to the European. So it should be some adaptation, it should be some, appropriate processing of this data. So how it can be resolved in the AI now? Can these studies, when the algorithms already designed, let's say, and many of them are for Chinese population, can these algorithms designed for Chinese population be later used on Caucasian population, Europeoid population? So probably Dr. Lee may start answering first, as he already tackled about that, please, and then others.
Okay. I think this is a very classic challenge in AI. They have the computer scientists. They have always tried to develop AI algorithms that can think like humans. So if AI can think like humans, they will solve these problems. I mean, you say that algorithms developed on Spectralis cannot be used or have poorer performance on images from Topcon, Zeiss. So think about that. If you are a physician and you learned how to read the images from Spectralis, then after you switch to Zeiss or Topcon, you will learn quickly, right? But for AI, it's quite difficult. Currently, the solution is that we collect a large amount of data on the new device, and then we fine tune the model. So the performance of the model on the new data would be better. So that's the most popular solution right now. But now there's a new possible solution is that we can use the large language models or large region language models. For these models, they have now obtained some kind of capabilities like human. They can perform some kind of reasoning capability. So if you train them on a large amount of data, say from Spectralis, and then you collect a relatively smaller amount of data on Zeiss and tell them that these are, similar imaging data, but from different devices. And then they can think like humans and they can learn like humans. You don't need to collect a lot of data like in previous research. So these are the current two solutions, I think. But still, I think the scientists, they still need to think about some new structural design of algorithms to make it more like human, and then maybe we will have some new solutions and even more powerful solution for this problem.
Спасибо. Thank you very much. Dear colleagues, thank you very much for very interesting information. And let me say a word in this discussion. We speak a lot about visualization using OCT. OCT is very popular now. It's available. And we try to use AI for OCT pictures. But historically and clinically, optic visualization was and is also important. Anterior chamber, gonioscopy. So all that also gives us a lot of information. And actually, clinically, later on, we cannot completely replace this information just with OCT. So what is your position? What do you think on what are the perspectives where there is a borderline or threshold between the complete switch just to OCT and nothing else? And where still there is a place, a niche for classical optical visualization, and what are the perspectives of AI here? And maybe you can speak about it, how AI can be used in classical visualizations. Thank you. Please speak up. Who wants to answer? Who wants to answer, colleagues?
No one.
No, what's that?
Let
I
me
just
start.
heard.
Did you hear the question? Did you hear the question? Gonioscopy and standard visualizations, where is their place? Because now mainly OCT is a food for AI. And what about gonioscopy pictures and other types of analysis? Let's say angle analysis using AI. If we talk not about the width or particular, let's say, segments, then truly in this case we can do it with OCT, yes. But for example, if we, let's say, want to see other details located not around the circumference, or let's say if the patient already had surgery and we see already changes, then we need both optical picture, gonioscopy, and something else, and AI that would be trained on gonioscopy and on the classical picture. So what do you see the perspectives here? Where are we going to move? Please speak up.
Okay. Let me speak something. Even though I think I didn't catch all of the question, the scene, what you answer. I just think about that in the clinic. We need to detect the angle very frequently for the glaucoma diagnosis. Professor Benjamin Xu to talk about how to use an AI to detect angle closure, to use an ASOCT. I developed the gonio diagnostic gonio system based on the volume scan, that the 3D source OCT, also to detect the angle closure. So there are many ways to detect the angle. Try to help the doctor to diagnose angle closure glaucoma, open angle glaucoma, and then the peripheral cilicia, blah, 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 blah. So I think that the question is great. There are so many things, but in the clinic, in the real world, not all of the country, not all of the district, the hospital will use their ASOCT. For example, they even have no OCT and even have a Casio OCT, really a modern style. So actually, I mean, the world changes so fast. The AI development should be moved fast and fast than we thinking. Okay, now we haven't finished the AI part, and the large language model already coming. So we need to keep the pace to do the AI, to do the large language model, to get a modern thing. But on the other hand, we need to face the reality in the real world when we detect the angle closure. Actually, we don't need to use the OCT. For example, in the clinical, we only use slit lamp. Slit lamp, we just take a 1 second look. You can see the peripheral anterior chamber. That is deep or the deep or shallow. Okay, and then you can see this is angle closure glaucoma or open angle glaucoma. So based on the data from the slit lamp to measure the depth of the peripheral anterior chamber, I think it's a good way to help to detect angle closure. So this is another way to help that we're using the low cost, the low effective machine to help to do the AI. So I think we can from a different way, from the one way to their reality. In other way, we need to keep to doing the higher modern stuff. I don't know if you can catch my point or not. Professor Ching Yi-Chen, can you?
Yes, I totally agree with Professor Zhang. So basically, the gonioscopy still have its advantage, right? For example, gonioscopy allow us to do the dynamic, gonioscope, right? To see whether the angle, in addition to net angle, is there any PAS? And basically, ASOCT cannot, detect PAS, right? Even with AI, I think the current ASMOCT doesn't have a required resolution to detect PAS, anterior synechias. So basically, I don't think that AI is going to replace gonioscope at this stage. But AI, with the AI plus ASOCT, right, at least provide tools, right, to assist us, right, in the clinical diagnosis of angle-closure glaucoma. For example, I know that for non-glaucoma specialists, right, they don't have sufficient experience, right, in reading the ASOCT scan. So I think with AI, at least, where AI tool can assist in the interpretation of ASOCTs, but it cannot replace gonioscope.
But for my board, I totally believe that in the future, the OCT will replace goniotomy. When I run a study about the digital gonio system, okay, that one not only can rapidly differentiate the narrow and the open angle, and also detect the peripheral anterior synechia based on the 3D. The 3D means it's a volume scan, okay? The volume scan in the open angle glaucoma, the anterior chamber, the volume is bigger, right? It's bigger than the shallow anterior chamber in the angle closure glaucoma. So at that time, I'm really proud for myself, my team, that we developed a digital gonioscopy the algorithm. I believe in the future, this one will totally replace the gonioscopy. Okay, because whenever you got the OCT, the patient just a 1 second to measure, and then the volume, how big he is. Okay, maybe like a 300 volume. Another one is 500. You gotta cut it off, and then oh, this is a suspect of angle closure glaucoma. And in the future, when the colorful of the imaging comes out, and then you can see the anterior synechia in the angle, the angle, and then you will see where is the synechia, where is the what's light. So I really believe that you will replace the gonioscopy. That is why I writing this. I already published 4 books. Okay, the 3rd book is just writing down the gonioscopy examination and the UVN and ASOCT. At that time, I spent 1 year to writing this book. I believe that the gonioscopy one day will gone away. Okay. This is my opinion.
Пожалуйста, но не это, что скрининг...
Thank you very much for your position. But glaucoma screening that Professor Cheng was talking about would be mainly done for the patients with the closed angle glaucoma. So can we expect that primary screening for closed angle? What can we expect in this case? Primary screening for closed angle glaucoma. How can be done in the future? What do you think?
Well, from the screening point of view, right, it still depends on whether the screening program is cost effective or not, right? Based on the ZEP study from Zhongshan Eye Center, right? It also tells us that doing LOPI is not really necessary for all the eye, right, with angle closures, right? So it still depends on the cost effective, right? if we want to detect the glucomatous optic neuropathy, right? There's no difference between open angle angle closure because this might be the same, right? But whether we need to detect angle closure, right, is detectable. But at this stage, actually also depend on whether we have a efficient cost-effective tool to do the detection. At this stage, I don't think, I mean, it's quite, at this stage, I think SOCT is still quite expensive, right? So it's unlikely to use the SOCT to do angle closure screening in the populations, right? We can apply SOCT in a clinical setting, but I think at this stage is how to do it in a community setting in a large scales. So I don't think we are ready to screening for angle closure yet. And again, cost effectiveness is also important considerations.
Спасибо, коллеги, спасибо за
Thank you
интерес.
very much. Thank you for very interesting discussion. And now we are moving on.